Let's go ahead and look at section 2 of chapter 7 called special right triangles. And so we're looking at right triangles because we have this little angle here. And this one's special because it's an isosceles triangle, which means that two sides are the same, and that means their opposite angles are also they're congruent. So their measures are the same. That means they are congruent. So we can use this and we can solve for our hypotenuse, right? We know how to do that. We know how to use Pythagorean theorem. So if I add my two smaller sides together after I square them, I will get my hypotenuse squared, right? So to get my hypotenuse, I just need to square root both sides. So to figure out my hypotenuse, see, I have to take my two sides and square them, and then square root that answer. And that's what you did in 7.1. Well, with this special right triangle, we say that these two sides are the same. So those are going to be the exact same. So it's like having A and A, or having B and B. So either way, we're squaring those two. And then we're going to square root them to find our hypotenuse. To find the hypotenuse. So they use letters S and S. So that's the same thing. S squared plus S squared, and square root that. That will give me my hypotenuse. Well, that's pretty nice because if I have S squared and S squared, well, that's just two S squareds, right? So that's just two of them. Right, so I have two S squareds. And I square root that, 2s squareds. Well, I can't simplify the square root of 2, but I know what the square root of s squared is. That's just plain s. So the s would come out, right, because I have a pair of s's there. S squared means I have a pair of s's. And the square root 2 stays in there. So my hypotenuse is equal to my one side times square root 2. And that's what we're going to be using on this special right triangle called a 45, 45, 90 triangle.